to start recording this. So, and we also went over the process of thicknessing a board using the joiner and the planer and the drum sander. We went over the process of ripping a board to final accurate width using the jointer and then the table saw. We've gone over safety on the table saw. We've gone over safety on the joiner. So in other words, following our order of operations, we have a very specific order in which we move through this shop from machine to machine with our material. And that order of operations is faces, then edges, then ends. In other words, thickness, the faces, width by treating the edges, and length by treating the ends of a board. Okay, that's our order of operations in that order. Thickness, width, length, faces, edges, ends. Okay, so we've done faces and edges, and granted it was quite a while ago, you probably don't remember it, but we've done it, and we'll go over it again, so don't sweat the details right now. But we have not touched on the miter saw. The miter saw is the last step in preparing a board for use in a piece of furniture. Now that does not include joinery like dados and rabbets and dovetails and things like that. It's just getting a board to the proper dimensions, okay? Getting it to the proper thickness, then getting it to the proper width, then getting it to the proper length. So we're gonna talk about length today. What you have in front of you is the proper term for this machine is a sliding compound miter saw. Now, for our purposes in this shop, we basically just call it a miter saw, okay? Now, a lot of people call this a chop saw. I've even seen some of the videos online of guys that are supposedly professionals, and they call this a chop saw. This is not a chop saw. A chop saw does one thing, and one thing only. Most of the time, chop saws are found in a metal shop, okay? But a chop saw does one thing and one thing only, and that is to cut 90 degrees, just like that. That's all it does, okay? This happens to be a sliding compound miter saw. Now let's break that down into what each of those words mean, right? Let's talk miter first, okay? A miter is an angle, such as this, on the end of a board. Pretty straightforward. It can be made by unlocking the bed. This is the bed or table. These two pieces are the fence. Unlock it, little button right here, push it. You can change the angle of cut. There are graduations in a plate right here that tell you what angle it's going to be at. There's actually little notches in here that allow the machine to positively lock at the most commonly used angles, 45 degrees, 22.5 degrees, things like that. Okay? So if I lock it at 45 degrees and lock the table, I can take a board, if I can get that little thing out, okay, and I can make a miter cut. Okay? Okay? That is a miter cut. Now, a miter is not necessarily 45 degrees. It can be any angle like that. But imagine the picture frame. Okay? That's a miter cut. All right? A cut in the other direction on the end of a board. I don't know if you can see this, but there's an angle this way. That's a bevel. Okay? That can be made by standing the board this way and making the cut. Or laying it down and changing the angle of the head, okay, or the motor itself, the blade. So that's a miter cut. This is our miter cut, okay? The reason it's called a compound miter saw is because if you've ever seen crown molding in a house that's mounted up in the corner where the wall meets the ceiling, where it comes together at the corner, okay, that's a compound cut. Basically what it is two angles being cut at the same time. You can't make those compound cuts for things like crown molding in a house a single cut at a time. Both angles have to be cut at the same time. That's a compound cut. And an example of that is this. There is a miter on this piece. Now, let me see if I can bring it up a little closer so you can see it. Okay. There's a miter on this piece in this direction. Okay. There's a bevel in this direction. that cut was made in one fell swoop. In other words, the bed was angled, and then the head was angled to whatever settings were necessary. And then that cut was made all at one time. That produces something like this, okay? So you see how those two angles come together. I don't know if you guys can see this very well, but you can see the angle it creates at the bottom and on the inside, okay? So that's a compound miter. So that's the compound miter portion of this machine. The last word in its name, if you will, is sliding, okay? The only reason it's called a sliding compound miter saw is the head slides. What that allows you to do, if that head did not slide, if this was simply a 12-inch compound miter saw, not a 12-inch sliding compound miter saw, the 12-inch just tells you the diameter of the blade. That's all it is. If this head did not slide, when you made your cut, the widest board you could cut on here is about 6 inches. Okay, you couldn't put a wider board on here and cut it. That sliding action brings it out so that you can cut a board up to about 12 inches wide. So if I had a board about 12 inches wide, I could cut it to length on this machine because it slides. So that's a sliding compound miter saw. Okay, that's where the name comes from. You guys only need to worry about calling it a miter saw. When we walk around the shop and we talk about a machine, or we ask a question about a machine, all you have to do is say miter saw. You don't have to say the whole mouthful. It's not worth it. Okay? But it is not a chop saw. Okay? So, some basic safety requirements on the miter saw. Okay? Your board must be at least 6 inches long in order to cut it on a miter saw. If your board is less than 6 inches long, this little guy is about 5 3/8 inches long, okay, about 5/8 shorter than 6, you cannot cut it on a miter saw. Your hand is too close to the blade. Since you have to hold the board tightly against the fence and tight to the table when you make a cut, that places your hand too close to the blade. So it's a 6-inch minimum length on the miter saw. That's actually one of the safety test questions. Okay. Second thing, since we have to hold on to the board with one hand and make the cut with the other hand, you can do it either way. You can have your right hand here, your left hand here, or you can switch over this side, whichever is more comfortable. You can work to the left of the blade, or you can work to the right of the blade. It doesn't matter, whatever's more comfortable to you. But what you cannot do is cross your arms. You can't put your right hand on the left side of the blade and your left hand on the machine. Vice versa, you can't put your left hand on the board over here to the right of the machine. Because what that does is it puts your arm in the path of the blade. Let me do it from this side. Put your arm in the path of the blade. Okay? So it's either like this or it's like this. You need to hold your board firmly to the fence and firmly to the table. Now, let's say, for example, you walk up to this machine with a board and you place it here. You see, I have this board for a reason. There we go. Now, right now, let's see, this will be a better edge. I know you guys can't see it very well. Oh, this is good. But, okay, your board must be in tight contact with the fence on either side of the blade. In other words, there can't be a gap between the edge of the board and the fence here or here. I'm not talking about way out here or way out here somewhere. I'm talking about right here and right here. It also needs to be tight to the table right here and right here. You can see right now, this board is not. I can slip my rule under there here and here, and I can slip it in here, okay? This is a situation that can cause a kickback. And on the miter saw, a kickback is when the board pinches the blade, in other words, closes on the blade as it's being cut, and forces the head of the miter saw to jump up in the air, throwing the board up, okay? If you've done everything you're supposed to do properly prior to coming to the miter saw, in other words, if you've done the thicknessing process properly, which is created two nice flat parallel faces, and then you've gone to the joiner and the table saw and you've done the edging process properly, in other words, you jointed one edge flat, straight, and square, And then you've gone to the table saw and ripped the opposite edge flat, straight, and square. So what you have now are two flat parallel edges and two flat parallel faces. If you've done those two things properly in the right order before stepping up to this machine, there's no way it's not going to be tight here and here, because you're looking at a flat surface on the edge of the board and a flat surface here. It's going to be in contact. If you've done the thicknessing portion properly, you've got a flat surface here and a flat surface here, it's going to be tight to the table. So if for some reason you get a kickback on the miter saw, you've screwed up somewhere in the processes prior to coming to this machine. You've done something wrong, or you've done something out of order. In other words, if I take a rough board right on the rack and I bring it straight to the miter saw and go to cut it, you're asking for trouble. Okay? So the processes we do in here and the order in which we do them are critical at each step. This is the last step in prepping a board for use. Okay? So that's tight to the tent, tight to the table. A couple other things. When you make a cut, okay, if you have to cut more than one board to the same length, okay, let's say, for example, you're building a ladder, okay, and the ladder has steps or rungs in it, right? All things you grab onto, you walk, climb up on. If you're making a ladder and each one of those steps, each one of those rungs is a different length, that's one jacked up ladder. Okay, you go to the sides of the ladder, it's going to be like this all the way up. It's not functional. It's not going to work right. Unsafe. So if you're making a ladder, you have to make absolutely sure that each one of those steps, each one of those rungs is exactly the same length. There's only one way to do that correctly, and only one way to ensure that every single step is the same length, and that's by using a stop. Okay, we have a piece of material that we keep here at the miter saw. It actually says, I don't know if you can see it or not, we're going to end up making a new one here anyway. Miter saw stop. It's got a word that says blade with an arrow pointing that way, and it says this side faces you. So in other words, if I'm working on the left side of the machine, I'm going to put it like that because the arrow's facing the blade and the writing is facing you. If for some reason I decide I'd rather work on the right side of the machine, arrow's facing the blade, the writing is facing you. Okay, it doesn't matter which side you work on, as long as it's set properly. It's either going to be like this or like this. Okay, so let's say I want to cut a bunch of board to 10 inches long. I'm going to take a tape measure. I'm going to set it right here on the table. Okay, I'm going to bring my blade down, and since I'm working on the left side, I'm going to put my stop on the left side. I'm going to measure from the left side of the blade to the end of the stop. So I'm going to bring this down right on top of my tape measure. So the edge of the tooth is on the right side of the 10-inch mark. It's right at 10 inches. I'm going to bring this stop up right to the end of the tape. Take our clamp, hopefully without moving the stop, and I clamp it down. In this shop, we always try to measure twice before we make a cut. Measure twice, cut once. I pull the tape away, put it back snug up against the end of the stop, bring it back down, and check that I've set it to the right length. Okay? Now, I'm going to make my cut. When I cut a board to length, it always takes 2 cuts to cut it to length. Before I can slide this end up to the stop, I have to make sure that this end is already square. If I try to slide something like this up to the stop, it's not accurate, either doing it that way or that way, because my end is not square. Okay, I don't have the 90-degree angles everywhere that I need them. So the first cut you make on a board is just a trimming and squaring cut. All you do is take enough off the end to make sure that the end of that board is square, that it's trimmed and it's square. Now we can slide it up to the stop. And make our cut. Okay. So it always takes 2 cuts to cut a board to accurate length. Now, also, whenever you make a cut, you're going to let that blade come to a complete stop before you bring it back up. And this is why, especially when you're using a stop. Watch what happens when I bring this back up. Watch the board. You see it move? These teeth grabbed the end of that board and moved it. Okay? Now, if you do that while the blade is still spinning, okay, you're taking a chance on those teeth that are now moving, grabbing that board and flinging it out at you. So you always have to make sure that the blade has come to a complete stop before bringing it back up. Okay? Next, never start the machine in contact with the material. That goes for any machine in here. Never start a machine with your material in contact with the cutter, the blade, the router bit, whatever the case may be. Never start it with it in contact with it. Now, let's say, for example, you've measured the proper length that you want, and you've made a line across the face of the board where you want to cut it. Okay? Let's say that I'm going to keep this piece, and this piece is going to end up being scrap. I'm going to have an X here on the scrap side. This piece I'm not going to keep. So that when I come to the miter saw, I know that I'm going to place my blade. I can bring this right down on top of my material, touch it to the surface of my material, and make sure that my blade is on the X side of my line. If I cut on the right side of that line, this is going to be short by 1/8 of an inch. That blade is 1/8 of an inch thick. If I cut centered on that line, this piece is going to be shy by 1/16 of an inch, which happens to be half of the thickness of the blade. I want to cut on the side of the line that I'm not going to keep, my scrap side. This is my good side. My blade is on this side of the line. Okay, so I can bring this down and touch that blade right to exactly where I want. I'm physically touching the surface of the wood. That's fine. But I have to bring it up, start the machine, and then bring it down to make my cut. Okay? So the last thing I want to talk about in regards to the miter saw. Yes, the miter saw is the last step. Now, I shouldn't say the last step overall. That's actually a really good question, Richard. The miter saw is the last step in getting a board square, getting it to the proper thickness, getting it to the proper width, and then finally on the miter saw, getting it to the proper length, okay? There could be other procedures you need to do to a board to get it ready for use in a piece of furniture. You might have to create some joinery like dados or rabbets or pocket holes or some way to join it to the other board that's going to be joined to. You might be putting a decorative edge or a decorative end or routing around it to something like that. Those all come after these 3 initial face, edge, and end steps, okay? So there's other things you may have to do to your board, but this is just getting it ready, getting it down to the final dimensions that it calls for in the plans. Now, no, not only for furniture, for anything. Well, heck, building a house. You know, you'd want everything square. I would think you'd want everything square when you build a house. End up looking like Dr. Seuss's worst nightmare. Furniture, cabinetry. Imagine a picnic table where the boards weren't square. Imagine a chair where the boards weren't square. Imagine anything made out of wood. Okay, say a cutting board. That's not a piece of furniture. It's just something, you know, if it's not square, it's going to look funky. It's not going to be right unless it was intentionally made not square. Imagine a chessboard. Okay, chessboard's not a piece of furniture. It's a piece of game, whatever you want to call it. If the individual spaces on the chessboard aren't square, if the board itself isn't square, it's not going to be right. So it goes for everything. I can't imagine too many things. In fact, I can't even think of anything off the top of my head where you just take pieces of raw lumber. I just thought of one. Pieces of raw lumber that are put together to create a piece of furniture. Have you ever seen those live edge river tables where they take epoxy and they pour it between the rough edges of a board to make a table? The faces have been treated, but the edges have not. A shelf, I've seen live edge shelves, but a shelf, 99.99% of shelves, unless there's some kind of art piece, all the shelves have to be square, okay? So yes, we need to get everything square. Now, the last thing I want to talk about on the miter saw is what we call feeds and speeds, okay? There are 2 basic ways you machine or mill a piece of lumber. You're either going to feed the lumber into the machine yourself. Table saw is a good example. You're going to feed the board into the table saw through the blade. The bandsaw is a good example. You're going to feed the board through the bandsaw blade, into the bandsaw blade. The router table, you're going to feed the board across the table and across the bit. Our edge sander, our disc sander, our spindle sander, you're moving the board against the cutter or the sanding head. The second way you do it is moving the machine through the board, okay? The miter saw is a perfect example. Your board stays static. You do not move your board. You move the cutter through the board. Same thing on the panel saw, the panel router, things like that, okay? So that's two basic ways to machine a board. You're either moving the board or you're moving the cutter, okay? So on the miter saw, we're not moving the board as we make the cut, right? We're moving the cutter, okay? Now, on the miter saw, this blade is going to rotate at a specific speed. We can't change the speed that this blade rotates, okay? On our router tables, anytime you use a router in here, most of our routers are variable speed. In other words, there's a little dial on them. We can change the speed of the router bit anywhere from about 5,000 or 6,000 RPM up to 21,000 RPM. So we can alter the speed of the cutter, okay? On the table saw, the dado saw, the panel saw, the band saws, the miter saw, we can't change the speed that that cutter's moving. The only thing we have control over is our feed rate, how fast we move the cutter through the material, or how fast we move the material through the cutter, for example, on the table saw. That's our feed rate, okay? The rate at which you feed a piece of material through a cutter, or the rate at which you feed a cutter through the material, has a direct effect on the quality of cut. Let me show you what I mean by that. Okay, I have a piece of pine here. I'm going to make a normal cut on the pine, how I would normally do it, okay? I start up here, never down. I start all the way up. I let the blade come to a stop, then I bring the cutter up. The whole time I'm holding this tight to the fence and tight to the table. That produces a nice clean cut, okay? Now, what if I increase the feed rate of the cutter through the material dramatically, okay? I can't really slow it down a whole lot more. That's not going to really change the quality of cut on this particular machine. But if I speed it up, the quality of cut changes dramatically. See if you guys can see this. I don't know if you can see that, but here's the one that I did real fast. See how crummy that cut is? Here's the one I did slow. Nice, clean, smooth cut, okay? So I don't know how well you guys can see it. I can't see it for squat on this because it's focusing on the miter saw, not this. So I don't know if you can see it. But you can definitely, there's a definite difference in the quality of cut. So our feed rate has a direct effect on our quality of cut, okay? That's very, very important. We tend to use our senses in this class a lot more than you might imagine. If you move the board into the blade on a miter saw, you are in big trouble, okay? You no longer have control over that board. It's gonna do whatever it wants. So it has to be static. It can't be moved. You're moving the blade. Any machine in here, you're either going to move the machine through the board, like the miter saw here. The board has to be held in place tightly. That's being done with your hands, okay? For example, on the table saw, where you're moving the board through the cutter, what controls the board as you're moving it through are two things. Number one, the fence. You have to keep the edge of your board tight against the fence as you feed it into the blade on the table saw. The second thing that controls it is, I just lost it. I just lost my train of thought completely. Most of what controls the board on the table saw is keeping it tight to the fence and tight to the table. So yeah, anytime we're moving the cutter, the board has to be static and held snug. Anytime we're moving the lumber, you have to have something to put it against. In other words, you can't freehand cut on the table saw. There are a couple machines, well, there's 1, 2, 3 machines I can think of off the top of my head that you do cut freehand. and that's the bandsaw, which we're going over tomorrow, the edge sander and the spindle sander, where you're moving the material while the machine is running, okay? But we're not moving the material while the machine is running on the miter saw, the drill press, things like that, okay? So that's our little feeds and speeds thing. Some of the machines in here, we have control over both. A good example is the CNC routers that we have here, the computer controlled routers that we have here. We program the speed of the spindle or the bit itself, and we program the speed at which the bit moves through the material on the CNC. So we have complete control over that. Very, very good control. The jigsaw, okay, there's another opportunity to explain something here. The jigsaw is a handheld power tool, as would be a handheld drill. Now, the jigsaw, you're moving the cutter through the material. If you don't clamp the material down or hold the material down in some way while using a jigsaw, you're never going to be able to make an accurate cut. So in that particular situation, it's very similar to the miter saw, where your material stays static and you move the cutter through it, okay? The puppet, what do you mean the puppet? I don't push things. No, Richard, at 6 inches, if it's less than 6 inches, you cannot cut it on the miter saw. If it is 6 inches, you should be able to hold it with your hands. If there's a problem, if there's something about cutting a small board that's like at 6 or 7 inches long that makes you nervous, we have other ways we can deal with it. We'll deal with that on a case-by-case basis, okay? So it's one of those things that if we get into that situation, we'll deal with it when we get to it. There's other ways to cut a board that's small like that we can deal with, you know, but that's another reason that the miter saw is the last machine we use in the order of operations. For example, the minimum length allowed on the table saw and the jointer is 12 inches. In other words, if your board is less than 12 inches long, you cannot rip it to width on the table saw, and you cannot joint the edge or the face on the jointer. So if you go and cut a whole bunch of boards to 10 inches long on the miter saw, and then go to the table saw to rip it to width, you can't. They're too short for the table saw, okay? Also, if you did not do the jointer and the table saw, if you didn't do the faces first, and then the edges, and then the ends, there's a good chance you're not gonna be able to keep your board tight against the fence or tight against the table on either side of the blade at the miter saw. So it's a process. If they change the size of it, I'm not sure I understand the question. So, I mean, yeah, one of the things you guys will realize is when you come in here, you're going to make mistakes. You're gonna screw up and you're gonna cut something too short, or you're going to do something out of sequence or something like that. And it's one of the reasons we have scrap bins here, these big blue rolling carts where you throw basically firewood into. You're going to make mistakes. That's just the nature of the game. I've been doing this for, geez, 43 years, and I still make mistakes. I don't know anything about woodworking in 43 years of doing it when you look at how much information there is out there. It's an incredibly difficult art to get proficient at. All we can do is try and minimize the mistakes. Yes, you can use a bigger piece of material. In other words, if you make a mistake or your board's already too short for the miter saw, we've got to start over. We've got to go back and, so in other words, if you need a piece of wood that's 2 inches long, and you're starting with a board that's 6 inches long, that might make you a little nervous going to the miter saw with it. It's going to put your hand pretty close. So if we start with a board that's longer than we need and cut that 2-inch piece off of it, that's how we do it. No, that's a really, really good question, Jacob. I'm glad you asked that. Are we going to have free time to make whatever we want? In beginning woods, okay, you're told what you want, you're provided the projects you need to make. In other words, there are no allowances for, okay, I've finished what I had to make, now can I make what I want? That doesn't occur in beginning woods. That's what we do in intermediate and advanced woods. In intermediate or advanced woods, you have the ability to choose from a huge, like, 1,000 or more projects you have to choose from. That's where in intermediate and advanced, we get to the point where you can start creating the things you want to create. Now, there are some limitations to that, but we'll learn more about that when we get back here. We'll talk about that in more depth. But yeah, beginning woods, normally you'd make a single drawer nightstand. In a 9-week course, there's not enough time for that. So I'm actually at the point where I'm trying to figure out what to have the beginning students do if we do come back. So we'll figure it out as we go. I'll have something ready for them when they get here. But what have I forgotten about the miter saw? Let me see if there's anything here I've forgotten. Okay, now let me show you what's going to happen tomorrow. Okay, I'm going to share the screen and give you an idea of what's going on. Wait a minute. I need to open another window. All right, so let's go here. All right, so here's our class. Okay, here's beginning woods right here, manufacturing 1. Okay, so if you look at today's module for Tuesday, all right, and I can't see the chat window right now if you have a question, but I will answer a question once I get out of this share mode here. If you look at Tuesday here, what I've done is told you that we're going to go over the miter saw, blah, 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 safety requirements, stuff like that. And then I've pulled a series of questions from the safety test. This is the test that you'll have to pass once we get back to in-school classes, that you'll have to pass before being allowed to do anything in the shop. Okay, what I've done is I pulled some questions off that safety test. The safety test itself consists of 50 questions. Now, some of these questions I pulled out of the safety test relate directly to the miter saw. For example, how many cuts does it take to accurately cut a board to length on a miter saw? The answer is 2. The first cut is a trimming and squaring cut. The second cut cuts the opposite end, getting the board to final length. Okay. Here's another question that applies directly to the miter saw. What machine would be the best choice to accurately cross-cut a board? That's what we're doing at the miter saw, is a cross-cutting operation. That's 5.5 inches wide, the miter saw. Okay. Here's another one that relates directly to the miter saw. A board must be at least 6 inches long to safely cut to length on the miter saw. Okay, there's something wrong. Let me see here. I'm going to show you. Okay, I'm going to show you. All right. So this is actually what you're seeing right here is just in Tuesday's module. So if you go to this week, the 6th week, January 4th through the 8th, and you go to Tuesday, that's right there. Okay, that's all right there. Now tomorrow, what you're going to see, I haven't put it in there yet, but when you go to Wednesday, what you're going to see is an explanation of a quiz that we'll be taking. All right. I'm going to pull 5 questions from the actual safety test and make a quiz. Okay. We will go over those 5 questions tomorrow before I let you go to take it. Here's another thing you need to know. Okay. You guys pay very, very close attention to this because this will help you in a huge number of ways in the future. Okay. No, it's going to be tomorrow. Yeah, it'll be tomorrow. Okay. If you go to my website, and I'm going to show you how to get there and what the address is. The website is www.gphsmanufacturing.org. Okay. That's the web address. In tomorrow's class, that will be listed here. Okay. And there will be a couple other links listed here. And I'll tell you what those links will be. So on my website, over on the left-hand side is kind of the menu. Okay, this takes it so you can just email me. This is kind of about the classes, blah, blah, blah. What you care about the most is this one right here where it says traditional woodworking. If you click on that and you scroll down towards the bottom of the page, you're going to see a bunch of downloadable files. Okay, the first 2 are the ones you're concerned about. This very first one, when you click on this download file, this is an actual copy of the exact safety test that you would end up taking when you show up here for in-class instruction. The 5 questions that will be on the quiz tomorrow will come directly from this test. They will be worded exactly the same. I'm not going to change a thing about the questions. The only thing that will be different is the number. The number on the quiz will be questions 1 through 5. These might be like, for example, where's this? Here we go. Number 26 is a board must be at least 6 inches long to safely cut to length on the miter saw, okay? It won't say number 26. It'll be either number 1, 2, 3, or 5. I'm not going to, the numbers are going to change, so that doesn't matter. Anyway, I'm going to pull 5 questions for the quiz directly from this test, okay? Now, if you go back and look at the second file, this is the first one we just opened. It's just a copy of the safety test. The second one, this will be linked in tomorrow's module as well. There will be a clickable link right there in the description of the quiz and all that stuff that takes you directly to this. So you won't have to navigate to my website and then navigate to here. It'll be linked in there. So if you click on that, this is a copy of the safety test with all of the correct answers, okay? So if you don't know the answer to one of the questions on the quiz, all you'll have to do is go back to the module where you started, you know, Wednesday's module. You'll go back to here. You'll look at Wednesday here. I'll go through the whole thing. You go back, okay, here's Wednesday. And in here, there will be a clickable link that takes you directly to this, okay? All you'll have to do is go through and find the question. It's gonna be worded exactly the same, okay? All you'll have to do is go through and find the question and it'll have the answer. A board must be at least 6 inches long to safely cut to length on the miter saw. There's another one down here. What machine, blah, 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 blah. I probably won't use one of these because it uses choices. There's one down here somewhere. I don't know. There's, in other words, the questions are going to be pulled from here exactly the same, okay? So all you'd have to do if you have a question about, if you have a concern about one of the questions, is go back. You'll be taking the quiz, you know, you can always open a second tab or something like that, no big deal. And then, I don't know the question of this one, click on that link. There'll be a blue link right here. It says woodshop safety test answer key. You'll click on that. That will open up and you just find the question in there. Oh, there's the right answer, false. There's the right answer, true. Okay, it'll be right there. Okay, so that stuff will all be right there. Okay, yes, we'll be taking it tomorrow. Yeah, it is a free aid, and every quiz is going to be done the same way here. In fact, I want to explain something to you, assuming I have time. I got just a couple minutes, so I'm going to explain something to you. In a normal class, 18 weeks long, you're in here 4 days a week, an hour a day. In a normal situation, if this coronavirus thing had never happened, in a normal situation, you spend the first 4 weeks in Beginning Woods learning safety. You will see, during those first 4 weeks, you will see that safety test at least a dozen times. You will sit in the classroom, I don't know how many times, 8, 10 times. I will put this test up on the screen. We'll go through every single question and answer over and over again over the course of 4 weeks. We will be out in the shop with the test in our hand, going over every single question at each machine that it applies to and explaining the question and the answer at the machine. In other words, a practical demonstration of the question and the answer and why it is the way it is. A couple days before the test, before you physically took the test in week 4, you would be handed a copy of the test. You can sit there and go through the test. Any questions you don't know the answer to, you can raise your hand and ask, and I'll give you the correct answer. The day that you would take the test during the 4th week, I would hand out a copy, I would put the test up on the screen in front of the class, go through every single question and answer, turn the screen off, and then hand out the test. So in other words, before you ever took the safety test during a normal semester, you will have seen it a ton of times. You will have gotten the questions and answers a ton of times. You would have had opportunities to ask questions and get the answers that you didn't know a ton of times. The whole idea is to beat this into your head so much that when you walk into the shop, it's second nature. It's like taking your driver's test and answering the question that's got a picture of a stop sign. And you answer the question, you say, what does this stop sign mean? And you answer it right, and you say, it means to stop. If you walk out of there with your brand new license, you get in the car to drive by yourself the first time, and you see a stop sign, and you forget what it means, and you plow right through it, you're gonna T-bone somebody, or somebody's gonna T-bone you, okay? What I don't want you to do is forget what you learned in the safety portion of the class when you walk out in the shop and get ready to work. That's why we go over it so many times before you ever take it. You guys will not take that test until you physically come back to school, okay? I'm not going to make you take that 50-question test while you're in remote learning. We will take short quizzes that are taken from that test over the course of the next 3 weeks to try and cover the entire test, but it'll be 5 questions at a time, and you'll have access to the answers through that Woodshop safety test answer key. Okay, so that's probably going to do it for today. We're running out of time. Thank you guys so much for getting here on time and being here. I really appreciate it. You guys have a great evening. Take care of yourselves, and I will see you tomorrow. Okay, bye-bye, folks.